This video will cover the topic, solving a radical equation that simplifies to a linear equation, one radical advanced. Let's look at an example problem. Solve for v where v is a real number. Our first step is to isolate the radical to one side of the equation. This is done by subtracting 1 from each side of the equation. Now we square both sides to eliminate the radical sign. This results in 4v plus 17 equals 9. Our next step is to isolate v to one side of the equation. How do you think we can do this?
Wouldn't we subtract 17 from both sides of the equation?
That's right. We now have the equation 4v equals negative 8. Now we divide both sides of the equation by the coefficient of v, which is 4. This results in v equals negative 2. We can check our solution by substituting negative 2 in place of v in the original equation. When we do that, we can see that we have the square root of negative 8 plus 17 plus 1 equals 4. We add the terms under the radical sign, which results in the square root of 9 plus 1 equals 4. The square root of 9 is 3, and 3 plus 1 equals 4. This verifies that negative 2 is the correct answer. Let's try one more example. Solve for x, where x is a real number. In this example, the radical is already isolated to one side, so our first step would be to square both sides to eliminate the radical sign. This results in 13 minus 3x equals 4. What do you think we should do next?
We need to isolate x to one side, so we should subtract 13 from both sides of the equation.
That's right. This results in negative 3x equals negative 9.
The last step would be to divide by the coefficient of x, which is negative 3, and this leaves us with x equals 3.
Great job! And to check if you found the correct answer, you can substitute 3 for x in the original equation. This results in the square root of 13 minus 9 equals 2, and the square root of 4 equals 2. So from this, we can see that x equals 3 is the correct solution.
So to summarize what I just learned, the first step is to isolate the radical to one side of the equation. Then, we square both sides of the equation to eliminate the radical. Next, we isolate the variable we're solving for to one side of the equation, usually through addition or subtraction. Finally, we divide both sides of the equation by the coefficient of the variable, and this results in our final answer. We can also check our answer by substituting the value into the original equation.
You got it!